All right, guys, so today's going to be a review day. First of all, I want to start off by saying I apologize for Wednesday. I definitely ran out of time for the Python lecture, and I felt I left a lot of you guys unprepared for some of the challenges. Hopefully, you guys were able to go over some of the Python stuff in your discussion groups, but I mean, that falls on me. Like, yeah, I wanted to get more of that material there, and I was unable to complete it. So, yeah, apologies to everyone. I didn't want to leave you stranded for the challenges or make you feel unprepared for it. So yeah, today we are going to be going over some more Python stuff just to complete some of the basics in case you guys didn't go over it in your discussion groups. If you did, then I guess this will be a review, which say it mostly will be a review day. So yeah, I'm just going to continue some Python stuff that wasn't in the first lecture, and we'll go from there. All right, so let's see. I think we left off talking about some basic data structures. So I think we talked about tuples, we talked about lists, which are basically identical to JavaScript arrays. We talked about dictionaries and how they're pretty similar to objects in JavaScript with a few key differences. One being that you can trust the insertion order. So that's kind of useful. I'm not sure if we talked about sets, so I could quickly mention them if I didn't get into that. So let's talk about sets. A set is pretty similar to what we saw in JavaScript, so there's not too much new there. I can declare a set by simply saying set. So we use a set and curled, or I guess rounded parentheses to declare a set, an empty set. You could also do something like this. So this gets maybe kind of confusing, but you can use angled or curly brackets for sets, which is the same as for dictionaries, but you're not going to have key value pairs. Instead, you're just going to have values. So this Python can detect this as a set and not a dictionary because you only have single values. You're not having key value pairs like dictionaries. So if I wanted a dictionary, I would have key value pairs. Just for example, I would do something like something and then 5, and then have more values. Does that make sense to everyone? Basically, both use curly braces for both cases, but sets only have single values. So as we talked about before with JavaScript sets, the same applies for Python sets. Sets essentially are data structures that have unique values, as opposed to lists can have multiple values of the same values in there. So like my list, if I had a list, just compare here, I could do like 5, 5, or 6, 5, 4. So in this case, I have 2 5s in here. That would not be allowed in sets. Even if I had it here, it would actually just filter this 5 out. So if I wanted to print my set out, it should remove the duplicates for me automatically. So again, that can be useful based on what you're trying to do if you just want unique items and not duplicates. So let me print out my set. And let me comment this out, not to distract you guys. Clear that and run my code. All right, so one thing you should notice is that some of these items got rearranged. So the ordering in sets cannot be guaranteed, much like we talked about with objects in JavaScript. Like I have an 8 here first, then a 9, then a 5, and 7. I actually don't know how sets go about organizing their data. I don't know why these items flip, but that's going to happen. So again, there's no ordering in sets. The sets provide you unique items, but no guarantee of what order they'll be in the set. So as you can see, the 5 got filtered out, as in I have 2 5s listed here, but my output only has 1 5, and that's because the set just automatically ignores duplicates. Yeah, so that's kind of how sets work. I think we saw this with lists, but you can also do this. You can pass in a string, and it'll kind of filter stuff out. So if I have like Mississippi in here, it's going to just take unique values, so it won't have duplicate S's or P's or anything. So let me just copy that, paste this. And run that again. And I get an error. All right, so my set has S, I, P, and M, which are the unique letters in the word Mississippi. And so that's just another way you can kind of get unique letters out of a string in that case. All right, so those are sets. Those are some data structures to know about. Sets, as I said, you won't use them too extensively from the challenges that we do. I don't think I use them in any of the challenges. You might find an application for them, but it's just another data structure to be aware about. Dictionaries and lists will be your primary data structures that you'll be using. through this cohort. All right, so let's move on to some more basic stuff just to go over them. I'm not going to spend too much time on them because I think you're pros at it. Operators and comparators. In JavaScript, there are operators and comparators. They're pretty much the same in Python. So like if I want to do 1 + 1, that's going to equal 2. I'm not going to do all the math operations, but you have your basic plus, minus, multiplication, division, and you also have your modulo, which is the remainder if you want to find the remainder for operation. The one I want to focus on, because JavaScript does not have something like this, and this is pretty useful. I've used it a lot actually. Is the double, I guess, slash sign. So this is a division. However, this is an integer division, meaning it will not produce a decimal value. So just to go over an example, let's say I have x equals, I don't know, 43 and y equals 10. If I do something like this, x divided by y, and print it out, I'm going to expect that I'm going to get 4.3 out of this. And I can't have stuff like this going around. Save that, clear that. All right, so I got 4.3 as expected because 43 divided by 10 is 4.3. But let's say I just wanted the integer value. And again, this might have been useful for some of your challenges on Wednesday. I understand that if I do x divided by y, or double slash, that's going to produce just the integer value. So the 0.3 won't be part of the equation. So let's run that again. So I got 4.3 from the first operation. The next one just gave me 4. So again, that's pretty useful, just getting the integer value in cases where you just want that and don't care about the remainder. So that's a nice little operator that Python has, which JavaScript does not provide. So in JavaScript, as
does it always round down? Ankur, sorry to interrupt you.
No, absolutely. So again, I guess I should have prefaced with that. This is a live lecture. If you guys have questions, stop me. This is not, I guess, a webinar format where we want you to just kind of just observe. This is going to be interactive, mostly because today is a review day, so you want to field your questions and answer anything that's on your mind. So in JavaScript, you guys might have seen this before, but just go over the same example. If I have x equals 43 and y equals 10. In this case, if I just want the integer value, I got to use an operation called math.floor. And this is a built-in, math is a built-in library to JavaScript. Floor is just a function provided on that. To answer your question, yeah, I believe it'll round down always. So we could try with negative numbers, and I think it'll still round down. I don't know if it rounds towards 0, but that's a great question to ask. So I actually am curious. But yeah, it won't round up. So if I have 49 here, and I have y equals 10, to answer your question in this case, x divided by y will still be 4. Yeah, so it won't round up to, it won't round up 4.9 to 5. I'll still get the 4 out of it. Let's run that for good measure. Yep, still got 4. I want to see what happens if I do have negative numbers. I don't know if it rounds towards 0 or rounds down all the time. So we're going to learn this together, hopefully. All right. So,
that's still going to be.
All right, so we got -5. So it looks like it's always running down, not towards 0. So in this case, this produces -4.9, and then this rounds it down like away from 0 when it's negative. All right, that's good to know about. Just to complete this example, if I were doing this operation, I gotta have my lets to be proper here. If I did this, math.floor would do the same thing for me, because there's no divide operator in JavaScript. So that's JavaScript way, and this is the Python way. All right, so that's a good operator to know about. The rest of the operators are pretty similar to JavaScript. The key thing to note is if in JavaScript you have and, or, these are the keyword and the keyword or. I'm not writing legit syntax here, but if I want to do an operation like if x is greater than 10 and y is greater than 10, you just literally write out the word and instead of using double ampersand or double quotes for and or. If you want to do a not, you just type in not. So this goes back to Python being a lot easier to read and to develop with. Just reading these ands, I think, is a little easier, just as humans, rather than reading ampersands and pipes in logic. So those are logical comparators. The basic ones in JavaScript, like you have greater than, equal to, less than, those are the same in Python and JavaScript. So those have not changed for you. One thing I did want to focus on, sorry, let me pause for questions. Since we are live, are there any questions on the basic operators? So if I want to do not, I can insert a not here.
Can you, it might be a good idea to show how to test for evens and odds. That's gets a lot of people.
Sure, absolutely, Brian. Thanks for that suggestion. Let's go with, all right, so let's say we want to test for evens or odds. I'm going to have something called my list. And just to be clear, lists and arrays are essentially the same thing in JavaScript and Python. Python, they're called lists. I think in JavaScript, they go with arrays. So let's say I have a list of various numbers. I'm just randomly typing some stuff in. All right. So Brian's suggestion was, let's figure out how to test for even or odd. So I'm going to create a new list. And that's going to be empty here. So I guess my task that I just made up right now, I want to filter out all the even numbers and put them into my new list, as in just append my new list with only odd values. So let's write in, we're gonna need a for loop, and we're gonna go over looping again. Hopefully you guys were able to go over that in your discussion groups, or were able to find it yourself, but there are a few different ways to loop in Python. The easiest way for lists is just to take, use the in operator for n in, and then my list. And this will basically iterate through any iterable item, which lists are. And I need a colon to start a new block, and then tab. So tabbing is your delimiter in Python. That's it auto tab for me, which it's quite convenient. I don't want to manually tab all the time. So in this case, I want to insert items if they're odd or even. So let's say my new list. And I'm going to append. So this is just one of those things you get used to. In JavaScript, you'll be pushing into an array. In Python, it's .append. And then the value n. So in this case, if I run this for loop, it's going to copy all the values from my list and put them into my new list. However, in my made up case, let me put a comment with that. Only copy odd values. So how do I determine if something is odd or even? Brian, do you have any ideas how I could figure this out?
I use the modulo or modulus.
Yep. So the modular operator returns the remainder of any division. So in this case, if I have something like this, it's going to divide n by 2 and then give me the remainder for it. So if I'm testing for odds or evens, you usually want to use the value of 2, because if something is equally divisible by 2, then you know it's even. If it's not equally divisible by 2, as in the remainder is 1, then you know it's odd. So in this case, I want to see if this does not equal 0, meaning that it's an odd number. And then if I do this, it'll only append new items that are odd. So if I give this a whirl, hopefully I should get odd numbers. And
shouldn't that be not instead of the, didn't you use JavaScript there for the not?
I think you could use this also. I might be wrong. Let's find out. Yeah, so you could use not equals, just like JavaScript. The not, I guess, the not keyword. I could also do something like if not equals. This is essentially the same thing. The not becomes useful in other cases where you don't have like direct equals. Like if I want to do something like this would work. Sorry, this would not work. So I could do an if statement like this. So anything that's non-zero, I guess that's something I should cover, is evaluated to true. So it's sort of like implicit conversion, which I said Python doesn't do all the time. In case of Booleans, it'll be able to, this would work also. So in this case, if n is anything that's not 0, that'll evaluate to true, and then it'll still do this operation. If I want to do the opposite, like if I wanted to do evens, I could insert a not here, and this would basically negate this value. So if it's a 1, I guess if this is a true value, the not will negate it to a false value. Does that make sense? All right, so that's kind of how lists work. Before I move on too much, I think I need to talk about a very important concept that many of you guys may understand already, but I want to make sure everyone's on the same page. And that has to do with copying values. Let's say I have a list, 1, 2, 3, 4. And then let's say I create a new list from my original list. Now, let's say I take my new list and let's say I append a new value. Let's say I just want to add on to it a 5. So just make sure everyone's following here. I have a list. I copy it. I append 5. So let me print out my new list and see what happens. My new list. Let's give that a run. I can clear my screen. All right, so I got 1, 2, 3, 4, 5, which is what I expected because I had my original list. I copied it, added a 5. But let's take a look at our original list actually and see what that's doing. I would assume it's 1, 2, 3, 4, right? So if I clear it, okay, so I actually got 1, 2, 3, 4, 5 with my original list. So does anyone understand what's going on here?
Yeah, you're referencing a spot in memory, not both variables are referencing the same spot in memory.
Absolutely. Yeah,
Is
so
it
this is,
by reference?
sorry, what was that last part?
Pass by reference?
Yeah, so for primitive types, so primitive types are ints, I guess, floats, Boolean, and string, and maybe there's a few other primitive types. For primitive types, you're actually copying values. So I have x equals 4, and I do something like y equals x, and then I do y equals y plus 1, or let's just do plus equals 1. Sorry. So in this case, I have x equals 4, and I assign x equal to y. In this case, y is copying the value of 4. It's not pointing to what x is, if that makes sense. So in this case, if I change y to like y equals y plus 1, it's not going to modify x because x is still pointing to 4 because it's a primitive value. So again, there's primitive values, which are your basic types, int, float, bool, and string. And then you have your, I guess, data structures or non-primitive types, such as lists, dictionaries, sets. And when you, I guess, assign them, they're actually creating copies to the reference, not to the actual objects. So they're not copying the actual object. And I want to make sure this point is clear. It's very important and can get you into trouble if you think somebody's actually copying, but it's actually copying a reference instead. So in this case, with the x and y's, x equals 4, y copies the value of 4 into its memory, and y can do whatever it wants with it. It's not going to modify x anymore. However, in this case, when I do this assignment on line 16, that is basically pointing to the same object that my list was. So my list got created. My list is pointing to someplace in memory, as Brian said, to this list that I created. This assignment lets my new list also point to the same exact thing. It's not a new copy. So if I did actually want to do this as I intended, I would actually have to make a copy of my list. One way to do that would be to use your slice notation. So I could do something like this. This will basically create a new array and then let my new list point to it. So if I ran this code right now without the x and y's, and of course I get some errors. All right, save that, get rid of that. All right, so in this case, it worked as I originally wanted it to. I have my list, and my list gets copied. All the values get copied to my new list. So basically, a brand new list get created here and assigned to my new list. So now when I modify my new list, it's not modifying the original list that was being pointed to. Is that crystal clear to everybody? Because again, this is a very important point. And if it's not clear, please ask questions.
So Encore, is that the same? Is that the Python equivalent of the spread operator?
Not quite. So this syntax is called slicing. So this basically goes through my list and grabs values. You can specify which values you want to copy. For example, I could do start at index 0 and copy until just before the third index. So in this case, it'll copy 0, 1, sorry, 0th index, first index, second index, but it won't copy the third index. So if I ran this, my new list would be 1, 2, 3, and then a 5, if I am not mistaken. Yep, so in that case, it didn't copy the last value. The spread notation, again, I guess I haven't found a Python equivalent. There might be one, but the spread operator essentially just breaks it out of a container in JavaScript. So then you just have individual values from a container.
I think you can use a double asterisk as the spread operator.
Like that?
Yeah, I think if you do something like that in brackets.
Brackets being like this?
Yes, square brackets around the whole thing, including the asterisk.
Okay, let's give that a try. I'm gonna do that right here, but I'll print it out and see what happens. Thanks for that, Greg. Let's do that. So you said, will this create a new list with it though, or not?
I think the
It
double
should-
asterisk is a keyword argument, a kwarg. So it's supposed to turn things into almost like an object.
Gotcha. Yeah, this will work with dictionaries. I'm not sure if it works with lists. I'm getting some syntax error here.
I thought kwargs were the equivalent of the pen or the dot 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 in Python.
Sort of. So yeah, kwargs would actually still have, you'd still have values mapped to an identifier, but it would just break it apart from a dictionary. That's something we'll go over, I guess, in a future lecture. So don't worry if you don't know what kwargs are, or
it's mostly used for passing an unknown number of parameters to a function. So if you want to write a function and you want to accept kind of an unknown number, you can use args, which is the single. And in args and kwargs, these are just conventional variable names. So you can call it whatever you like.
And don't worry if you know what any of that means, or don't know what any of that means. We're going to cover that in a later lecture.
Yep, kwargs and arguments, all that will be covered for sure. So don't feel lost if you don't understand that. All right, so that's an important point. Again, references versus values, great concept to know about. Definitely ask questions, research it if it's still kind of confusing, because it will get you if you think that you're just copying lists all over the place, but you're actually pointing to the same list reference, you're gonna get into trouble with your code. So, all right, so I wanna make sure I cover that before I move on from lists and data structures. Going back to comparators, just to wrap that topic up, there are some differences between JavaScript and Python in terms of how they evaluate or implicitly convert some values. So in Python, anything that's equivalent to 0, for example, value of 0 or empty string, or even such things as empty list or empty object, all of these items are considered false if it's just if you just have these as a conditional. So I have a simple example right here. My list is what I meant to call it. I have an empty list at the top, and then I have an if statement. So my if statement just has my list as a parameter. It's not checking anything about that list. And if that is evaluated to true, I'm going to print 1, else I'm going to print 2. So if I give this a run, as I said, if something's empty, that's considered false in this case. So anyone shout out, what do you think the answer is going to be here if I print this out, 1 or 2?
2. 2.
Yep. So in this case, I got a 2 out here in my console. And the reason being, as I said, this is an empty list that equates to false. Usually you don't want to do this. You want to be more verbose about what you're doing. Like in this case, I'd do, if len equal 0, or it's greater than 0, I'd do something like that. But just for this demonstration example, I'm just using it as a list. This is different in JavaScript. So another difference to point out, again, there's many subtle differences that you encounter. We definitely won't be going over all of them, but it's good to know about some of them that exist. So I have my JavaScript code up here. I have an array that's empty, and I have the same situation here. I'm just using my array in the if statement. If that's true, I'm going to print out 1. If it's false, I'm going to print out 2. So let's clear that, run node. My file is called hello.js. All right, so in this case, I got a 1. So as you can see, these are essentially identical pieces of code. Maybe I should split the screen. Should be using this feature more probably. So here's my JavaScript on the left side and Python on the right side. Same piece of logic. JavaScript prints out 1, Python prints out 2. So just another subtle thing to know about. All right, I'll go back to Python. Let's see, another concept I want to talk about, because I don't think we've talked about it, might be very basic. A lot of you guys might be familiar with it. It's operator precedence. So you can have multiple operators nested together, and there's going to be ordering, a predetermined ordering that that the compiler or interpreter evaluates your code. And sometimes it can get kind of confusing. So this kind of goes back to writing cleaner code. If you're going to have a line with like 20 different operations on it, it may be hard to read. Like there's still going to be a definite way it's interpreted. but you might want to clean precode in that case. But just for example's sake, let's say you have something like print -1 plus 2 times 3 power times 3 times 4 5 times 6. So some of this, we'll go back to your math phase where there's, math operator precedence. So in this case, if I'm looking at something like this, I'm gonna be like, well, I'd probably break that up into multiple lines. But for this case, I just want to talk about how this is evaluated. So operator precedence goes, exponent is handled first. So this gets first priority. So this will be computed first. 3 to the 4th power, which would be what, 3 times 3 is 9, times 3 is 27, times 3 is 81. So I believe this will be 81. And then after that, you do left to right for multiplication and division. So I believe this will be 2 times 81, which is 162. You'll divide by 5, but I'm using the double division sign. So that's actually gonna just get rid of the remainder. So it's essentially 160 divided by 5. So I believe that should be what, 32? Yep, 32. So I did all this stuff, and then I'm gonna do my addition and subtraction. One key thing, a negative sign or a positive sign before a number will get applied before any multiplication or any division or addition happens. So in this case, this is a -1. It's not like a minus sign. So like if I had, if I had like a -1 here, this negative gets assigned or evaluated first. But if it's like this, then it's -1. I guess I'm kind of losing you guys there probably. But just know that the plus or minus for a number gets evaluated before any multiplication or division or subtraction. So in this case, I have what, 32 here. Let's get rid of this. I'm gonna add -1 to it, so it should be 31, and then I'm gonna subtract 6. I think the answer should be 25. I actually don't know. Probably should have ran that before, but again, so I just want to, again, I did not go over all the precedents. There's a whole table you can find online with probably like 10 or 12 different entries. So all the math operations generally happen first, then comparators happen. So let's just say math operators. Then you have your comparators. So that's where you have like greater than, equal to, where you're checking like if stuff is smaller or bigger. Then you have your assignment. So if you're assigning something in a statement, that will happen next. Then you have your identity. So this is where you might use the keyword is or in. We've talked about in, where we saw a list where we did like a for loop where n in my list, that basically goes through, checks if it's, I guess in is a little different there. In is checking if it's in something. So if I do something like if my list equals 1, 2, 3, 4, I name my brackets there. I can use the in operator like if n in my lists. So this is going to check if the value of n, which let's say I want 5. If 5 is in my list, it'll do something. If it's not, then it won't do something. That's how the in operator is used for checking for, I guess, membership. And then there's also an is operator. The is operator is an identity. And that, we talked about that a bit on Wednesday. The is operator checks for identity. So if I want to say something like is x none, sorry, that's not how I do it. X is none. Again, remember none is just like null in JavaScript. So if I do something like if x is none, do something here. So this is checking if x is actually like the object of none. That's what is checking for. It's not checking values, it's checking the object itself. Versus in is checking membership. So is 5 a member of my list? So that's when is or n get evaluated after assignment. And finally, you will have your, what is it, not, and, or ors. So there's different levels to them. And within those levels, there are some precedents also. So for logical operations, and always gets applied to before or, unless you have parentheses and want to specify. So if I have something like if x greater than 10 and y greater than 10 or z greater than 15, in this case, ands always happen first. So these two things will be compared before this or gets compared with that. It's not just randomly picked. So even if I had something like this, where I have an or first or and first and an and second, the and always happens before any or gets evaluated. I'm going to pause for questions to make sure all this logical operator stuff and the precedence kind of makes sense. Questions? All right. So you guys are good on ands and ors. Again, if there's any more confusion, again, I didn't go over the extensive list. Just kind of Google online operator precedence in Python. You will probably find websites that have an entire table and describe it way better than I just did. But just know that there is a precedence. So if you're ever in doubt, you can Google it and kind of figure out what ordering your code would be in. All right, just to go over some for loops and if statements. I want to make sure everyone's clear on that. We kind of have been using them without kind of talking about them, but if statements, you have the keyword if, you have a condition, and then you have a colon, and then you have a block of code. So you can do whatever you want in here, like y equals 10, z equals 10, return y plus z. And then I could have it else. If I want to do something else, like y equals 7, z equals, I don't know, it's making up numbers, 88, return y plus z times 2. For example, I do that. Instead of having else ifs, as you do have in JavaScript, we use something called elif, which kind of just combines a word. I think it makes it easier to type. Elif is just else if combined as one word. So I could do something like y x greater than 20, do something else. Return y. I don't know what this program is doing, but it's just returning a bunch of stuff based on conditions. So you have your ifs, you have your elifs, and you have an else. But you always need a colon. I forgot my colons here.
Yeah, I was just about to ask about that.
Thanks for that. Yeah, no. I often forget those just from habit from C++. But yep, so that's your basic if statement. I think you guys are pretty comfortable with if statements, so don't want to belabor the point. But if statements exist pretty much in any language. That's kind of how they're implemented in Python. Let's talk about for loops. Again, I know we've been using for loops. You guys probably kind of discovered how to use them. There's the main way to do a for loop is you do for x. You can call this whatever I want. Let's call it whatever. And so there's this range function that will create a range object for you. So you could do something like this. And this is the common way you have loops. This range function is kind of smart. It knows kind of what you want to do. So in this case, if I have range 20, it's going to create a range object from 0 to 19. It's not going to include 20. 20 is not inclusive. So in this case, if I quickly do a print statement and print out whatever, it should print out the values 0 through 19. Let's just make my number a little smaller for console's sake, and then I can run this. All right, so I get 0 through 9, but not 10. So 10 is my upper bound, but it's not inclusive. So that's a typical way you will see for loops. Use this range operator is very useful. Let's say I didn't want to start at 0. I could specify 2 parameters for my range object. Let's say I want to start at 2 and go up to 10, but not including 10. I could specify 2 values. In this case, range knows that the first value is my starting index. The second one is my ending index. As opposed to 1 value, it assumes this is your ending index. So if I do something like this, it should start at 2. Yep, I got 2 through 9. All right. So there's a third parameter you could put in here, and this is the increment. So let's say I want to go over every other number starting at 2. And let's make this 13. This will go through this range, but skip over every other number. So 2. Let's say I did 3. This will start at 2. Take I guess add 3 and go to that index. So wherever the second index is, and then the 5th index. It's not going to care about what's in between. So let's see what this prints out. So it starts at 2, and then it goes to 5, and then it goes to 8, and then 11. So this is your increment value. This can be negative also if you want, but then you might have to adjust your range. Yep, so now I'm going backwards through the loop. Again, if you had it like I had before, like this would not execute. Actually, I'm curious what this will do. Yeah, so this does not execute because this is a negative increment, and my range is, I guess, going forward. So it's just going to say, all right, there's nothing to do here. One special thing, I don't think I've seen this in another language. You can add an else statement to your for loop, and this can be a little confusing. Maybe you probably won't be using this often, but it can be useful in certain cases. So let's say I'm going through a range, and if that range has whatever is equal to 7, I want to break out of it. If you guys are familiar with this break keyword, it's the same in JavaScript. It breaks out of whatever loop you're in. It'll break out of a for loop or a while loop. It does not affect if statements though. So this is going to break out of my for loop here. Don't need semicolons. So you'll run into these cases often where you might want to execute a loop and it runs to completion, as in it didn't find a case to break, or it found a case to break and you want to do something else. So in this case, if this loop breaks, it's going to ignore this else case. However, if this loop completes, it will get to this line, whatever's in my else case. And let's put another print statement like it says done. All right, so if I ran this, it's actually going to break my for loop once it hits a 7, because that's a 7 is between 2 and 13. It will ignore the else part of this. So let's give that a run. I should probably print out stuff. I guess I don't need to print out stuff. Basically, this loop is going through 2 through 13. It found 7, so it broke out of that loop. Sorry, I'm kind of all over the place here. All right, so it went. The loop went 2 all the way to 7. I hit my special case here, where I want to break when whatever equals 7. It ignored the else case. However, let's say I had this was whatever equals 17. This will never break, as in this loop will complete fully. In that case, my else case will be applied. So if I ran this, I get from 2 to 12, and then I get my hello world statement because this else case executed since my for loop completed. Again, this is a little more advanced. It is useful based on a lot of algorithms you might be doing, whether you break out of a loop or not. Having that else case makes it a little easier. If I did not have that ability, like in JavaScript, this is not possible. I would need some Boolean here that says, like, let's say I had a Boolean that says completed equals true. I would need to set completed equal to false, and then I would use that Boolean here. If completed equals true, then print hello world. Does that kind of make sense? So this is how you'd probably have to do in JavaScript. You need a Boolean to keep track of, assign that Boolean whenever you hit your special case, then break out of your loop, and then use that Boolean again. So it's a little less elegant in other languages, but the for else is a good mechanic that I really like in Python. A couple other things to go over for loops before we move on. If we have lists, we kind of did this before.
Question, Encore.
No, questions, yes.
For just a regular for loop, you want to go through print out 0 to 13 is the standard just to do 13 plus 1, so it's inclusive?
Yeah. So yeah, I do 13 plus 1 or just have a 14 in there. Just know that like the end value won't be part of your loop. It's just like in like JavaScript where you do like the I equals less than 10. That's essentially what the range function is doing.
Okay, thank you.
All right,
and while you're on this, Encore, sorry, just while I'm looking.
No apologies, this is live Q&A. Happy to take questions.
So with that range, the way you have it written, so with regards to the list, if you were to try and print out that list in that range, where would you put my list?
So yeah, it's a good question. So I have this list. You just use the in operator. So that will kind of go through the enumeration of your list. So if I want to do print out list, it's really convenient. It's basically the same in JavaScript, right? You can use some for loop, but it's a little different in JavaScript. You got to use of instead of in. This will go through all the values and print out all my values in that list. So I should get 1, 2, 3 without. Good note here, since I have a typo. In Python, true and false are capitalized. I think I mentioned that on Wednesday, but easy to forget. All right, I ran this, so it goes through my entire list. If I had a dictionary, you could do the same thing. Dictionaries are a little more complicated, of course, but I want to go over them because you're going to be using dictionaries a lot. Let's just have donuts. So I love donuts. Equals 1. Cookies, that can equal 2. You do need to use strings. As opposed to in JavaScript, you kind of just have a identifier. And what else do we have? Ice cream. All right, so in this case, I have key value pairs. The keys being donuts, cookies, and ice cream, the values being 1, 2, and 3. So if I wanted to go through a dictionary, I could do something like this. In this case, whatever will actually be my keys. And if I want to extract the values, I'd have to do something like, so whatever will be the key values. If I want to print that out also, I could do whatever and then that. So I could do that. All right, so in this case, I'm printing out whatever, which is my key, and then getting that value using that key for my dictionary. So this is one way to do it when you're iterating through a dictionary. You can do it another way. It's kind of depending on what your use case is, I guess, whatever you're more comfortable with. So I'm just going to name these a little better. Shouldn't name variables improperly. But I could do something like this. I could do key value, and then dictionaries have a function called items, which will give you key value pairs back. So in this case, I can just clean up my print statement. So this items is giving me pairs. So I'm getting two values back, a key and a value in this order. So in this case, I'll get a key value, and hopefully you should get the same printout as before. Yep, donuts 1, cookies 2, ice cream 3.
So question, when do you use the enumerate?
Good question. I should go back to that.
My diction.
So enumerate's good for lists. So if I have something like this, and once, whatever it was, 1, 2, let's add a 4, just change it up. Enumerate is good for lists. So if I want to do a for loop with lists, the normal way if it was for n in my list. So in this case, I'm getting the values out of my list when I do this operation. However, I don't know what index I'm using. So that's a little different as opposed to like for loops in JavaScript, where you're iterating using an index value. And so you have the loop iteration value with you. In this case, I don't know what index value on when I'm doing this type of for loop. So if I ran this again, it's going to be printing out. It's going to be printing out the values. So I get 1, 2, and 4, which is what's in my list. Let me just make those 2, 4, 6, just to make that a little clearer. All right, so I got 2, 4, 6 in this case. If I actually want to index, I could change this a little bit. So in this case, I'm going to add an I as my index. And this is the enumerate thing that you're mentioning, Brian. So enumerate, make sure I spell it correct. So if you use the enumerate function, this will produce a pair. This will be your, it's kind of like a dictionary where you have your key and value, but like lists don't really have keys, they have indices. So in this case, you're getting an index and a value back. So if I ran this and printed out index and value, I should get I should get 0, 1, and 2, because those are the indices of a list. Yep. In this case, I got 0, 1, and 2, which is the I values, and the N are just the values I was getting. What questions do you guys have?
So at this point, and sorry to keep being the one to ask questions, if what I was asking before kind of was more about the range on a list, right? So if you wanted to iterate over it, but you wanted to skip values.
You want to skip values. Okay, so let's have a little longer list, 8 to 10. And let's say I only want to print out every other value. So I might do something like 0 through length of my list. So remember, len is the way to get length from containers. And then if I want to do every other, my increment would be 2. So was there any specific question on how this worked, or maybe this kind of answer your question?
No, that answers it. Thank you.
Okay, yeah. So that 2 is going to say start with my starting index. Then every step I take will be 2 indices, not just 1. If you leave that off, the default is 1, because that's the normal case for most time we're going to do things. So in this case, I'll go through every item 1 step at a time. That 2 will just say go 2 steps, starting at your starting index. All right, so that's a bunch of looping. Just to wrap up our loops, we also have while loops. Nothing magical here. It's pretty much the same. Same as in JavaScript, so I'm not going to waste too much time on it. But if there's any questions, definitely let me know. You have a while loop, you have a condition, and then you do stuff in that while loop. Again, you have multiple items here. You need a colon. Don't forget your colons. You'll probably drop them. I forget them often. Print x, for example. So if I have x equals 0, this while loop will run until x is greater than, sorry, I will screw that up too. This will run until x is no longer less than 5. So I'll keep adding 2 each time on this loop, print out x, and then keep looping. I had a good question, I think, in my discussion groups. Just want to reflect that question. Someone asked, when do I use for loops versus while loops? And that's a great question. For loops generally I use for when you know how many iterations you need to do. So like often if you have a list, you know how long that list is. So you can just get the length of that list and iterate through all those values. So that's where for loops are useful. While loops, on the other hand, are used when you don't know necessarily how many iterations it might take. Like in this case, I could convert this to a for loop, it'd be easy, but if I had something like, or we're taking input from the user, this will theoretically can go on forever if the user never enters anything greater than 5. So if they want to just waste their time and keep entering 1, they can do that, and this while loop will continue. But until they enter something that's 5 or larger, this loop is going to continue. So in that case, as a programmer, I don't know how many iterations this loop will take. So that's where while loops are useful or more sensible, and then for loops are the other case where you know how many iterations it will take. All right, just about done here. Any questions about looping or conditionals or anything like that?
Ankur, you used pass keyword in the previous.
Yes.
What is that?
Thank you, Tasneem. Pass keyword, that's just a special keyword. I guess I need to talk about functions, so that's a great segue, thank you. I didn't explicitly talk about functions. Hopefully you guys kind of got familiar with them if you need to use them for your challenges. Functions are created by using the def keyword and then a name, so let's call it whatever. And then parameters, whether you have them or not, you gotta have parentheses. So let's say I want a parameter, let's call it x, y, and z. I can totally do this, have a colon that will start my function block, and then I could add logic here, like x plus x equals y plus z, return x. So that's kind of how a function looks like. Again, that's a very simple function. You could have default values. Let's say I want z to equal 88. That means if my caller of this function does not pass a z value, it's going to default to 88. So I could do something like print whatever, let's say 5 and 10. So in this case, I didn't specify a third value. It's going to automatically make z equal to 88. If I did specify a value here, like 15, then it's going to use the value of 15. So this is an optional parameter with a default value. Default values have to go at the end, so I can't do something like this. Pretty sure this would break because this in turn makes x optional, which the compiler can't figure out, like, are you actually providing an x value or is that a y value? If I do something like this, like now y is not defined. So basically, if you want to have default parameters, you got to put them at the end of your parameter list. The pass keyword, as Tasneem asked about, that's kind of what segued me here. Pass just says this does nothing. So if I did something like this and just had a comment like do something, I'll actually get an error when I try to compile this because this function needs at least one line of code in it. A comment does not suffice as a line of code. So if I ran this or tried to run it, I'll get an error because it thinks this print needs to be part of this function, I believe. Yep, it says expected indication block. So the pass statement just says I'm purposely doing nothing here, but it's a line of code. So it honors this as a line of code that does nothing at all. So it can be useful, like if I were developing a project and didn't quite want to define my function right now, I just want to declare it, I could just use, create it and write a pass in there. Another difference to mention about JavaScript and Python, again, Python is wild, wild west, as I kind of say, or say, JavaScript is wild, wild west, where there's less error checking. If I had a function like this, and I decided to pass it 3 parameters, this would cause an error because whatever only takes in 2 parameters, and I'm trying to pass in 3. Likewise, if I try to only pass in 1 and I don't have a default parameter set, this would also cause an error because this function is expecting 2 arguments and I'm only passing it 1. And when I say arguments or parameters, those are interchangeable words. However, in JavaScript, this totally flies. If you do something like this in JavaScript, z will just be undefined. Or if you pass in extra values, the extra values are just ignored. So JavaScript is just more flexible, but also can be more dangerous. Because if you think, okay, I need to pass in 3 values and I want to use all 3, but your function only uses 2 of them, you could get into trouble that way. So again, that's another difference between JavaScript and Python. JavaScript can let you pass as many or as few parameters as you want, and it'll just work with what it has. Questions? What questions do you have? None? All right, the final topic, Chad, I think, kind of mentioned this yesterday. So Hopefully it's not completely new, but the last thing I want to talk about are list comprehensions. And as I said, I think Chad covered it a bit yesterday. It's just another way to kind of initialize lists, I guess. You can use them for dictionaries also and for other data structures. List comprehensions kind of just make your code more succinct. Sorry, can't speak. I can use something like num for num in range 10. So this will basically run a for loop in here and then use each number and make that a member of this list. So if I ran this and did a print, it should create a list with values 0 through 9, because remember the last number is non-inclusive. And yep, I got a list, populated values 0 through 9. So this is just another way to kind of write, like I could do this another way if I want to. If I did a for loop and did num in range 10, this is exactly the same, doing the same thing, just takes a little more writing, I guess, is the trade-off. Does that make sense? So this and this, same exact thing. In this case, I guess a duplicate because I have two lists or one list and doing it twice. List comprehension can get more complicated. You could add in like conditionals. I could do if num modulo 2 equals 0. So in this case, I'm checking if it's an even value. Again, if you divide by 2 and there's no remainder, that says it's an even number. So in this case, if I ran this, I would expect that my num list only has even values because I have this additional if in my list comprehension. Yep, so I got 0, 2, 4, 6, 8 because I have an additional if. You can also add an expression here. So basically the format of this is you have an expression and then you have a for loop and then another condition if you need it. Again, you might use these. I mean, you can use a for loop and achieve the same thing. So list comprehensions are just another more condensed way to write the same thing without having like additional lines of code. But you guys may get familiar with them. If you guys don't like them, you're not forced to use them. It's just kind of a convenience thing at that point.
Can you also add an else on that line 1?
Line 1, like right here?
Yeah, after the if. So like return num modulo 2 if it equals 0, else return this.
I'm not sure. Let's find out. I don't know.
Yeah, I think you can.
Okay, so I could return 7 if it's not. Let's make it 77. I'm not quite sure the format here. Do I need like that?
When I've done that, the if statement had to be at the beginning, but that might work too.
Yeah, you can have if statements here also. So you could do like a ternary operation here. So I could do if num greater than 5 at it. So I'm gonna get rid of this else because I'm not too familiar with it. Apologize about that. So in this case, I'll run this for loop and then it will check this condition for those items, but then it'll do an additional check here. So I can have else here and say else have 88 inserted. So again, this is kind of hard to parse. So again, this is not maybe the clearest code, but you have a for loop going here with a condition, and then that pops out a value, and then we're having a ternary here. So this ternary says if num equals 5, use num, which is coming from our for loop, else use 88. So I have some syntax error here. Okay, so I'm not sure what that syntax error was. Basically, if num is less than 5, I'm populating 88, else I'm going to use the actual number, and that number has to be an even number. Again, this is a mouthful, it's confusing code. So list comprehensions can get kind of complicated. So that's something for you to kind of dictate how complicated you want to make your line of code or break it out to separate lines. So those are list comprehensions. Again, that's kind of a more advanced feature. It's a newer feature of Python. But if you get familiar with them, they can be useful with your day-to-day coding. All right, you guys good on the material for the week? Any questions? No questions. We got a smart group here. All right, if you guys think you're that smart, I'm actually gonna throw a quiz at you. So if you guys can, again, if you want to participate, I encourage it. I'm a competitive person, so I love kind of just like taking quizzes, seeing how I do. I'm gonna give you guys a couple minutes. Please go to this site, joinmyquiz.com/pro. and then enter the code of 601812. And so this will be a live quiz. It counts for nothing, so don't worry if you like fail it or if you don't want to participate. That's your option. But this will let you kind of compete against everyone else. There'll be a few questions. They will be timed, so I think there'll be either 30 or 60 seconds. There will be a timer that you guys will see. It's a multiple choice question. All of them are multiple choice. The way it works is the quicker you answer it, the more points you get. I don't know how the point system officially works. If you get it correct, obviously you get more points. If you get it wrong, I don't think you get any points. Don't rush yourselves though. Again, this is meant to be educational and also to see kind of how much information you've retained from the week. And we'll definitely discuss stuff. You guys will kind of hate me. I will say that up front because there are some gotchas in here. There are some code samples. Inspect them closely because I purposely put in tricky situations. And yeah, so the answer might not be as obvious as you think.
I posted the link in the Slack.
Thanks, Tom. All right, so yeah, I thought this would be a fun way to interact and kind of, again, test our knowledge from week one. So it's going to cover some Git stuff, command line, Python, JavaScript, pretty basic, but there are gotchas in there, and you guys will yell at me later for the gotchas, but I want to put them in there to have discussion points. All right, I'm going to give it maybe another minute if you guys want to participate. I see 32 participants, which seems like a great bunch. I see a squirrel in there. I'm not sure who squirrel is, but good luck to squirrel. I got K Smooth. Not sure who that is. Cool name though. All right, I think we got mostly everyone here. We have someone named Lighthouse. Great name to have. All right, let's give you guys maybe another 15 seconds.
1 second.
Questions? Yep. Was there a question out there? All right, so this is it's going to be multiple choice questions. Pretty straightforward. There'll be 4 options. Read the question. Hopefully there's no questions about the questions. I don't think I could pause it in between, but let's just see how this goes. All right, I think I see 39 participants, which seems like the entire class. Great to have everyone. All right, I'm gonna start. So on your screen, you should see the questions. On my screen, I think it's gonna show the same question. There'll be a timer, so don't feel too much pressure, but we're not gonna spend like 5 minutes on each question. I think it's 30 seconds for the simple questions and a minute for the coding examples. Good luck. Watch out for the gotchas because they are there. And let's begin. All right, first question we have is about Git. All right, so I created this awesome project on my machine, and I now want to version it with Git, so I can upload it to GitHub. What Git command do I use to achieve this? All right, time's going to be running out soon, so make sure you get your guess in. All right, you got 2 seconds. All right, let's see how you guys did. So I think the results will show up on my screen. All right, so 20 of you guys got the correct answer. So Git init is how you start a brand new Git repository. So there were, we've been using Git add a lot, and that is typically the way we do it with challenges. Git add commit or adds your changes to an existing Git repository. So when you do a Git clone, you're copying a Git repository, and you already have the repository set up. So add normally will add your changes to it. But if you don't have your project Git versioned already, you need to create a Git project with the Git init. Any questions on Git init or Git add? Hopefully you guys get familiar with Git as you go forward. Again, I am not a Git expert. I say this all the time. I kind of get more familiar with it the more I use it and kind of figure out new features as I need to. So yeah, just know Git init is if you get into that case where you created code, but it wasn't Git version beforehand. All right, no questions on that. We can proceed. Going once, going twice, no questions. All right. Next question is also about Git. All right, what are the proper steps for starting and completing a coding challenge? So this is a more typical case where we give you a coding challenge. Again, there's a lot of steps in there, so if you guys can parse the answers, but what are all the steps that need to be taken? There's a bunch of them. What's the correct order in terms of when we give you a challenge, how do you get it back to us? All right, let's see how you guys did. All right, you guys are smarty pants there. I couldn't trick you there. couple of you guys, I think what was, yeah, submit. I don't think it's just submit get command. It's very similar to commit in wording, I guess. So maybe that threw you off. But yeah, you guys got the process down. Again, you probably have done this at least a dozen times this week, but you fork first. So you want to copy it on GitHub. Then you clone it down to your machine. You modify the code, which is the hardest part, obviously coming up with the solution. Add your changes to your local, I guess, commit list. And then the commit pushes to your local repository on your machine. So you have a local history of your entire repository. The push action pushes it back online to your GitHub. And the pull request submits it back to our branch, which you forked from, so we can actually see those changes. All right. Seems like most people have this down, so good job there. Let's get a quick command line question in there. Just make sure you guys know your command line stuff. If I'm working on my command line, how do I create a new file? What's the command line command for a new file? You guys are answering this quickly, which makes me think you guys have this mastered. All right, we got maybe 6 more seconds for the 2 of you who haven't answered. All right, did I stump anyone here? Nope, seems like you guys mostly have it. I'm not sure if there's even a make command. Someone else, Chad, might have to overrule me here. I don't think there's a make command. There's a make directory command, which makes a new directory or folder. But to create a new file, you use the touch command. So again, hopefully you guys have been using the command line or familiar with it. But yep, touch is used to create a new file. So you do touch space, enter your new file name, and that should create it in the directory that you are in. All right, cool. You guys seem to be command line experts. Let's get into some coding. So these are gonna be a little more difficult. Hopefully you guys have enough time. These are a minute long. So I have a block of code here. I wanna know what the expected output is. So just to go over basically I have an array. This is JavaScript. I have an array. I'm using the filter function of the array and doing something with it. And I'm also chaining a map function to it. So it's a little complicated, but hopefully you can understand the flow there. So when I print out my new array, what is the output gonna be? Again, take your time with it. Make sure you understand what the functions do, and take your best guess if you're not sure. All right, I think we have about 10 seconds left. Hopefully it wasn't too short of a time to process the code. All right, let's see how you guys did here. All right, so not a lot of you guys got the right answer. That's all right. We will go over this. So I think let's dive into the code. I think I have it coded here. Where is it? Sorry, this was JavaScript. All right, so I have my code here. Hopefully you guys can see my screen here. This is the same snippet that I had in the image. Again, hopefully you guys didn't run out of time there. I don't know if it was too short a time. But let's just go over this and make sure we understand array functions. So I have an array with a bunch of numeric values in it. Whatever, there's 8 digits in there. Then I'm actually creating a new array. So I'm copying over the result from all this stuff. So the stuff I have highlighted is probably the most confusing part. So let's break it down. So the first thing is I have my array. I'm calling the filter function. So this is an array function that will essentially go over every item and then pass it to a function. So again, hopefully the fat arrow syntax is getting you guys. If you guys are unfamiliar with the fat arrow syntax, I'd say get more practice with it. We go over in discussion time. Yeah, so this is essentially a function that I've created on the spot. It's passing each item from the array and then doing something with it. It's returning, in this case, a true or false. And the true or false is the item divisible by 2 equally? If the number is even, I'm gonna get a 0 value out of here. So 0 means false. So again, there's a lot of processing there. I know maybe I could have written this a little more clearly, but essentially for every even number, this function is gonna return false. So anything that is even will not be filtered into my new array. So filter, if something returns true, means yes, it's true, I want this in my new array. So in this case, all the even numbers will be dropped out. So if you look at our original array, the 1, the 5, the 9, and the 3 should be dropped off by this filter action. All right, I'm going to pause there. Any questions on filtering? Does everyone understand what the filter function is doing? If not, we want to go over it and make sure you guys understand it. Don't be afraid to ask questions if it's unclear, at least even a little bit. Let's talk about it.
Yeah, so the filter just removed all the even numbers basically that were 0.
Yeah, so I made the condition if the item is equally divisible by 2, which means it's even, that's going to pass a false back. So that's where this is the implicit, like if something equals 0, that's implicitly gets converted to a false for logical conditions. So in this case, even numbers are dropped out, odd numbers remain, and then I have another chained action. So what is actually happening here, this first part that I've highlighted creates a brand new array. And on that array, I'm calling another function. So there's like a temporary array that gets created in the middle, and then I call the map function on that array. So the first block returns all the returns all the odd numbers. I think I said that incorrectly. Even numbers get dropped out, odd numbers stay. So the 1, 5, 9, and 3 stay. The 8, 4, 6, and 2 get kicked out. Sorry if I'm confusing you guys.
I thought it was the opposite. That's why I was asking.
Yeah, so yeah, this returns false for even numbers. So even numbers are booted, odd numbers remain. The map function takes everything in the new array and then does something to it. So the item is being passed into this new function, and I'm basically just adding 1 to whatever's being passed in. So if we did this kind of logically, the first action deletes all the even numbers. So let me kick those even numbers out. And now my array, my temporary array with this function is just 1, 5, and 9. And then each one of those items can get 1 added to it. So I should get 2 here, 6, 10, and 4. And that's what my eventual new array is going to get converted to or equal to.
So we don't have to declare what's that item is, right? Is it like just a random
temporary item?
No, item, yeah.
Item.
Yeah.
So yeah, this item is a parameter. So I can name this again whatever I want. I can name it whatever,
Okay.
And then say whatever, whatever. So again, you're passing in a parameter to a function. So this is how the fat arrow syntax works. Instead, if I wanted to make this maybe more clear, I could create a function that says add 1, and then takes in an item. So let's just call it item. Sorry, I'm in JavaScript.
So like, I want to know, like, where's the argument, like, for that parameter?
One moment. So I could write a function here, and then instead of having the fat arrow notation for my map function, I could simply have add 1 as a parameter. And so this parameter is a function, and that function is expected to take in 1 parameter. That's what map is expecting. So map is expecting a function that takes in 1 parameter, and that parameter will be automatically passed by map to this function. So maybe you're asking where this item comes from. That's what map is doing. Map is going through my entire list and taking each item 1 by 1. So like, again, I haven't actually looked into the code of map, but imagine it's like a for loop that's just passing each individual value to the function that's called. Sorry, did that answer your question, Tesney? Or did you? Okay. Yeah, so again, I could write it this way, have a function outside and pass that function to my map function. This would do the same thing. And so that's adding 1, and then so all these values get updated by 1, and that's my code.
And then add 1 is the callback function, correct?
Yep, so add 1 is what map is using for each item, and then I'm creating a new array. I'm not modifying my existing array. Map and filter all create new arrays. What questions do you guys have about this topic?
So one last question on this. If in your filter, if we were to go back to that, if item modulo 2 strictly equal 0, would that alter the result at all?
Like this?
Yeah.
Yeah, so this would alter the results because this is now saying for every even number, as in this, if this is true, as in if this is 0, then we're saying that even numbers are true. So sorry, I might be kind of butchering my explanation there.
No, that totally makes sense. I think that's what I saw when I was looking at the code. That's just kind of what my head turned it into.
Yeah, absolutely. Again, usually I would not recommend just writing logic like this. I usually like having explicit comparisons, which makes me, it tells my brain, hey, there's gonna be a true or false return from here. So yeah, this would flip the results. In this case, you get the even numbers and add that by 1. And Python still. All right, take my word for it. Yeah, so this will flip it. But I'm not able to run it right now. All right, you guys good with that? We can move on to the next question. Oh, Christian, go for it.
Is it a bad coding standard to use truthy falsies?
I'm gonna defer that. I actually don't have a good response to that. I think I would use truthy or falsy values. Like for example, if you have an empty string, you could just check empty string. I would say it depends on your case. I like being more explicit. So usually if I'm writing something like if string equals, I would do this check personally. Some people might just do like if not empty or something, or sorry, if I did like that. This condition and else if string, these two would do the same thing. So maybe it's not else if string were empty, this block of code would execute. This is the same thing. Sorry, I apologize. If string is empty, this would not execute, and this is the same thing. If string is not empty, that these two would do the same exact things. Because if string is empty, that gets evaluated to false. And in this case, if string is not empty, then we'd do this block of code. So string is empty here, this we'd ignore. If string is empty here, this would get ignored. But usually I like being explicit like this. It just makes it easier to read as a reader, I think. But I guess it's up to you, and I think Tom or Chad could probably clarify if falsy, relying on falsy and truthy rather than being explicit about it is good or bad coding standard. All right.
Real quick on that, if you're ever trying to rely on something to be undefined, you can't compare to undefined, so you would have to rely on its falsy value.
Gotcha.
You can't. Sorry, you can't. Never mind. That's you can't. It's not exactly.
So you're saying something like this in JavaScript?
Yeah.
So yeah, I think undefined is falsy.
Yeah.
Yeah. So I guess that would be a case where you might just want to use it rather than you can't compare it to undefined, I don't think. All right, so those are array functions. Again, get comfortable with them. You'll be using them a lot. They make your life a lot easier once you're used to them. So don't be afraid about if you're afraid of syntax, just practice them more. Fat arrow functions are useful with array functions. So with that, all right, let's move on to the next question. All right, make sure you read the code really closely. What is the expected output here? So I have a function called do something. It takes in either 2 or 3 parameters. And then I have an if statement, else statement, and a return case. So in the first case, I'll return y plus z if the if statement's true. In the else if case, I'll return x plus z. Or if none of them are true, I return x plus y. Again, make sure you read the code really closely.
I ran out of time.
Got a few more seconds left. Sure you get your answers in there. Take your best guess. All right, so there was a gotcha in this code sample. All right, so I think I threw you guys off. Again, you guys will hate me for these gotchas. I think 21 is the expected answer if this was coded correctly. So let me go to my example here. All right, I have this do something. For the 7 of you that got this correct, one of you guys want to tell me why that's correct?
Basically, I was for 10, which is actually equals to, I actually went for the x and y because z is previously defined. So just matched with the conditions with my input, and yeah, I followed it that way.
Okay, but there's a gotcha there, so I don't know if anyone caught it. So
what is the gotcha that even if it was, it's a truthy falsy value?
Kind of. So the key thing here, if you look here where I have highlighted, what's the mistake there?
You're assigning, not comparing.
You're assigning y to 10.
Absolutely. I need double equals to compare it to 10. So this actually assigns y to equal 10. So in this case, what actually is happening, y gets assigned to 10, and then this statement uses 10 as its condition. So 10 gets evaluated to true. So even though I'm passing 11 as my y value, this gets evaluated to true because I assigned y to 10, and then it just checks 10. Since 10 is a non-zero value, it's gonna execute this branch of code. Again, that's a gotcha. So again, always use double equals for comparisons. If you do this, you're gonna get some different values. So if I actually did a double equals, my output should be what most of you guys thought, which was 21. So let me run that to verify that. So I have the double equals in there. What are we in? Review.js. All right, so the middle value, don't look. All right, well, I kind of blew that. All right, let's run that again. No one looked, everyone had their eyes shut. All right, so 21 was the answer if I had the condition here. All right, so again, that was a gotcha in there. Make sure you use double equals or triple equals. Again, triple equals is the extra safe thing. Is everyone clear on double equals versus triple equals in JavaScript? That's another important topic for JavaScript, which doesn't exist in Python, but JavaScript can kind of screw you up there if you don't know the difference there. So make sure you know the difference between double equals, triple equals, and single equals. Single equals is assignment, double equals is implicit conversion and comparison, and then triple equals is explicit comparison. Any questions on that?
Is it generally better to default to explicitly equals?
Yeah, I always use triple equals unless I forget. Unless you want it to convert. So like, for example, if y was a string, in this case, let's say y were 10. In this case, this would equal to true still. If I had triple equals, this would be false. So I guess it depends what you want to do. If you want strings to automatically be converted, you might use the double equals. All right. All right. So we're going to go to the next question. There's a few more questions, and I'll get you into lunchtime. Hopefully, I won't hold you guys too much longer. All right, we're moving into Python. Hopefully, you guys are familiar with Python now. So we have this snippet. We have an array with strings in it. I'm using a for loop. Oh, sorry, this is still JavaScript. Sorry. I have an array with strings in it. I'm going in a for loop and converting it to an int, and then trying to push it into my array. What is my new array? And again, make sure you read the code closely. You guys will maybe find the answer, maybe not. All right, a few more seconds. Get your best guess in there. Watch out for the gotchas. All right, so again, you guys might hate me after this because there's a big gotcha in here. Hopefully you guys didn't see the, all right. So a lot of you put the last answer, which is what I wouldn't expect. And the only reason I put this question in here is because this tripped me up initially when I was working with JavaScript. So I wanted to put this in there because it tripped me up. Hopefully it won't trip you up as much. So 3579 is what you normally would expect if this were coded correctly. But there's one big gotcha that's not, usually it's not evident at all. So I had my answer before that I commented out. Again, I don't want you to hate me. This is just to make you aware of mistakes I've made so you guys don't make them in the future. In JavaScript, it's kind of confusing. The in actually is going through, I guess, the keys of the array or the indices of the array, not the actual values. When I did this initially, I was like, why isn't this working? Like I would expect n to be the values in my array. The key thing in JavaScript, you need to use of if you want to go through an array. Again, it's a minor change. It's easy to miss. Like, again, I would totally look at this code and be like, yeah, it should be 3, 5, 7, and 9. But the in is actually indices. So in this case, I'm getting 0, 1, 2, and 3, and I'm adding to that. So in that case, I'll get 1, 2, 3, and 4. Does that make sense? So the key highlight of this problem is always use of if you want to use this format for iterating through loops in JavaScript. All right.
What's in indicating here?
So in is actually going through the indice values, not the values at the
Okay.
end. So in this case, n is 0, 1, 2, and 3. Again, it may not be obvious. I just want to make sure you guys know the difference between doing for in and then for of. For of is used with arrays. Again, please don't hate me, but please know that difference. But otherwise, the answer would be 3, 5, 7, 9 if we had that coded correctly, or as expected, I guess. All right, next question. Now we're going to go into Python. All right, so we have this Python line of code. It's some list compression that's kind of long. If you guys aren't familiar with the I guess backslash, that just lets you wrap a line without Python having you complain. So don't worry about that black backslash on line 2. That's just extending that line to the next line without having issues. So this is a list comprehension. Again, we kind of went over this. I don't know if it's set in stone yet, but I kind of want to see how you guys do with this. All right, we got about 15 more seconds on this. Seems like I probably should have extended the time a little bit. I don't know if I could do that on the fly. I could pause the timer. I'll give you guys a few more seconds to get your answers in. 5 more seconds. Any thoughts? Any thoughts? All right, we're ending the question here. All right, what did you guys put here? All right, so some of you guys got the answer. Again, list comprehensions, especially the way I have it written, are not easy to parse. So again, that's maybe a reason not to use them that complicatedly. But just to break it down, just go over it one more time. We have fizz and buzz, which are going to be printed out. So this is a ternary operator. It's similar to what you might see in JavaScript with the question mark and the colon. So this is basically saying, if this condition is true, print out fizz, else print out buzz. So that's what the first part of this list comprehension is doing. But we need to do this part first, which is the for loop part of it. So this is basically going through my list, which is defined above. And then I have a condition for the values I want to extract. The condition is if that value is divisible by 3 equally or divisible by 4 equally. So basically, if I go through my list and look, all right, 9 is divisible by 3 equally, 4 is divisible by 3 equally, so is 12. 5 is not divisible by 3 or 4 equally. 8 is, 7 is not, 10 is not, 3 is divisible by 3 equally. So if from the first part, I should drop the values that are not divisible by 3 or not divisible by 4. Again, it's an or, so one of these conditions have to be true, not both of them. So I'm left with this list. Again, 9 is divisible by 3, so it's 3. Also 12 is divisible by 3, but also by 4. 4 and 8 are divisible by 4. So I get these values out of the first part, and then I do my ternary operation. So this is saying, if my given number is divisible by 3, make it a fizz. So 9 is divisible by 3, that's a fizz. 4 is not divisible by 3, so I get a buzz. 12 is actually divisible by 3 and 4 from the first part, but in this case, 3 is a key condition. So 3 is divisible by 12, or 12 is divisible by 3, I get a fizz, and then another buzz, because 3 is not divisible into 3 equally. And then I get, finally, a buzz. Sorry, I get a fizz. My last answer is fizz. Did I flip that? Buzz, buzz. Yeah. Sorry, this was flipped, but I think I was saying for this case. But basically, invert everything I said. So if I is divisible by 3, then that's going to be a buzz. Sorry, I should write better code. I apologize. This is checking that same thing. All right, list comprehension is kind of complicated, but hopefully you get familiar with them with more practice. I guess the lesson there is practice more with list comprehensions. All right, what's the expected output here? I have a list. I have a new list. I have a function that negates the values of the list. And then I'm doing some math there. So if you guys remember your indices with Python, you could have negative indices. And if you guys remember what that do, that could kind of guide you there. Also watch out for any gotchas maybe. But for the most part, hopefully you guys can get the correct answer. All All right, I know I'm eating into your lunchtime, but we should be done by 12:15 with the quiz. All right, I'm going to give you guys a few more seconds. Get your answers in if you want to take a guess. I'll give you about 5 more seconds. All right, I'm going to end this question. Let's see how you guys did. Answer is, we don't care about leaderboard. All right, you guys did really good here. I was hoping to trip you guys up with that copying situation here. So the main thing here, this is not creating a new list here. This is pointing to the same exact list. So when I negate my list with this function, my original list gets negated. So it seems like a lot of you guys caught that. So once I do this operation, both I guess references are pointing to the same thing. So I negated this original list. And so when I see my list here and new list here, those are actually the same exact thing. They're pointing to the same thing. I'm taking index 1, which is the second value. So if I negate my list, I'm going to get -1 here, -2, -4, -9. Again, because I didn't create a new list, I'm pointing to the same thing, which we went over. The first index 1 is -2 here. And then if you remember how negative indices work, in Python, this is a cool feature. It starts from the reverse. So -1 is actually this index. -2 is this index. So if I add those together, I'm adding -2 plus -4, and that's my value. And I print out that value. So I think you guys did a good job there. Hopefully you guys understand negative index notation in Python. You might see it in code and don't freak out if you like negative indices. That does make sense. It's a Python specific thing, so get familiar with that. Also, good job on identifying that this is not a unique copy. If I wanted to create a new copy, I'd use the slice notation, for example. All right, good job there. Any questions on that? Hopefully you guys are familiar with, again, copying a reference versus copying a value, or creating a brand new copy of something. There's a difference there. So make sure you're aware of that difference if still kind of unfamiliar to you. All right, more Python. There's a little trick here. The trick is for your benefit. There's no gotchas per se, but there might be kind of a lot of lines of code there, but if you can smartly break it down, you might be able to save yourself there. So again, this function is going to return either 1, 2, 3, or 4 based on some complicated looking conditions there. But if you guys can remember, kind of apply logical operators as we talked about them. I think actually Chad might have covered this topic on Tuesday. We got about 10 more seconds here. Timer's running slow. Take a stab at a guess if you're not sure. All right, you guys do well on this one. Fairly well, I think. Looks like 4 or 3 were the guesses there. So to go over this, again, it might have seemed like a lot of code, but if you understand short circuiting, it would save you your eyes some trouble there. So I have the code up here. So I guess the kind of trick to this problem is understanding how short circuiting works. So I'm passing a value of 10 and 20 for A and B. I have an AND here. So I have 2 cases I need to meet. I check A greater than 15. My A value is 10, so this fails. So in that case, whatever is here does not matter at all, because this is an AND. Both sides of this have to be true. Since this is false, I can, like reading this code, I can just say, all right, this case is not gonna be hit because A is not greater than 15. I don't even have to read what's after that. And that's kind of how the interpreter does it also. As it's executing, if this case fails, it won't even evaluate the second case. So I know this is false because A equals 10. Let's go to this case. Again, same thing going on here. I have a bunch of ands strung together. So you guys might have been looking at this like, okay, I gotta do all this multiplication and subtraction. Not quite, because if you do the first part, A times B, which is 10 times 20, that's 200. Is that less than 120? Nope. So then all this stuff does not matter anymore because the first case failed and I have a bunch of ands here. So I know this case is not going to get hit. So that saves me like both me looking at this code and the processor does not even attempt to formulate these answers because the first part failed, it can move on. Then we get to here. Again, this is where precedence comes into play. We have an or and we have an and. So if you guys remember from the precedence discussion we had, and happens first, and then you do the or. So in this case, I want to do the and. So I'm going to check this stuff first. Is B less than 10? No, B is not less than 10. Did I screw this up? I might have gotten the wrong answer. I apologize if I did.
Yeah, I could have sworn you said to do the and operator first. So that's why.
All right, I'm going to take a mulligan here. Hope you guys don't hate me any more than you already do. Yeah, I think this actually equates to false. Oh, no. We're right here. Sorry. I think we're good. So we do the and. Sorry, we're good. B is not less than 10. So this and part is false. However, we have an or. So we care about both sides of this. So in this case, A is greater than 5. Yes, because A equals 10. So this is true. So we don't care about the or part because we only need one side of an or to be true. As opposed to and, we need both sides to be true. So in this case, A is greater than 5, I can return 3. All right, so that's kind of have breaking down like the and or precedence and short circuiting. I have trouble saying that word. Short circuiting basically means you can ignore certain parts of the logic if you already have the result you want. All right, so that's why the answer is 3, because this part is true, the or is satisfied, so we return 3. All right, we're gonna have one more coding question, and then should be close to finish. Last Python question. Oh, I guess we're done with Python. I don't even know what question we're on. All right, this is just a poll. Kind of want to know what you guys enjoyed of the 4 that I picked for you. Def Grandma, Roman numerals, Armstrong numbers, or credit check. Which one did you guys enjoy the most tackling? Whether it's difficult or easy, enjoyable, whatever. We got a pretty good balance going here. I think credit check is in the lead by a couple votes. I think this tells me that you guys all enjoyed them equally. All right, that was really close. I thought that'd be a clear winner, but it looks like all challenges got equal love, which I guess is good to see from our end. All right, good to know that. All right, last question of the night, or the afternoon. It is not a coding question, but kind of want to just have a little fun question in there. All right, we got puppies going a lot. All right, this is pretty even also. I thought it'd be more of a preference here. Any more votes for the Chiefs? I'm actually rooting for the Chiefs. I'd love to see the Chiefs win out here, but it looks like the Chiefs are losing by 1. Anyone? All right, looks like the Buccaneers have it. All right, so for those of you guys planning to watch Super Bowl, hope you guys enjoy the game. I will be watching. I'll be rooting for the Chiefs, as I said. But regardless, I hope it's a good game. That was the last question of the quiz. So hope you guys enjoy the quiz. Hope you guys learned something from the quiz. Again, if something was unclear, whether it be list comprehensions, we got some winners here. Let's see who did what. Oh, wait. I was not answering. Who's me? That was not me, by the way. I don't know who me was, but
Yeah,
Me
cheater,
is that was
cheater.
me actually. Sorry.
Gotcha. No, you're fine. You're fine. But all right, cool. Good job, guys. You guys did great on that. Hopefully you guys learned from that. Enjoy taking a quiz. Definitely review stuff that's not familiar to you, whether it be list comprehensions. If you don't understand references versus values, again, definitely know your syntax. Again, I had some gotchas in there versus like the for in versus the for of. I feel like that was kind of a cheap question. I'll admit it, but I wanted to share that because I tripped up on it. All right, before I send you guys off to lunch, kind of want to just quickly point out the challenges, make sure everyone's clear on what's going on here. So we have a bunch of challenges we want you guys to do over the weekend. Hopefully you won't take up too much of your weekend. Definitely have some time for the Super Bowl there.
So
yeah,
practice with a pair. You need a pair programming partner for that. So I'll slack out pair programming partners, but everyone else or all the other challenges you can work independently or with your pair programming partner.
All right, I'm just gonna bring this up quickly and make sure there's a high level understanding of each problem. Again, I wanna get you guys to lunch, keep me long. All right, we have anagrams. If you don't know what an anagram is, basically an anagram is where one word can be, the letters in one word can be shuffled and produce another word. So in this case, anagrams, we're looking for, we have an input and then we have a list of matches or candidates we want to match with. So in this case, sorry, the screen kind of runs out here. We want to see which of the words from our list, which are cognac, saltier, realist, and retails, are anagrams of saltier. So I think you guys had an anagram challenge earlier, I assume, with part 2 being here. So we want you to do this challenge. If there's any question on this, we'll be available in the afternoon, but hopefully you guys are anagram pros by now. So yeah, if there's any questions on that challenge, let us know now or later when you attempt them. Character count.
I have a question on that one.
Yes, let's hear it.
Sorry.
You're good.
So if there's like, let's say if there's like 2 R's or 2 L's or something, and there's like a double, is that, does it need to have one, like the same amount of count for each character?
For anagrams, you got to use every letter exactly once. So for example, if you, let's say we had 2 R's in here, both R's must be accounted for in the word you're comparing against. So if I had saltier with 2 R's, I would need realist with 2 R's also to match it.
Gotcha.
Good question though. Then we have character count challenge. This one might have been part of the pre-work or maybe part of the, similar to one of the onboarding questions. Basically, you want to take in a string and determine and basically count how many characters each are in there. So in this case, we have A, B, B, C, and C. We want to output a count based on each character that's in there. So even if you had a sentence, an apple a day would keep the doctor away, we want to ignore spaces and still count every character that's a non-space character. Again, punctuation, we should not count. Only characters is what we care about. All right, so hopefully that's pretty straightforward. Palindrome challenges. We love palindromes and challenges. This one, this one you got to figure out if a word is a palindrome. So I guess we have a lot of word problems today. We got anagrams, palindromes. Palindromes is a word that reads the same forward and backwards, and this could be for sentences also. So we had, I think, a man, a plan, a Panama. There's some famous palindrome sentence out there. So you might have to deal with, oh, it's down here. A man, a plan, a canal, Panama. So you got to be able to handle cases where you have spaces and maybe capitalized letters, other punctuation you're not expecting. We only care about the letters themselves, not the punctuation like commas we don't care about. It's still a palindrome if the letters are the same back and forth. So that's a palindrome. Hope you guys figure out good solutions for that. Mode, I actually like this challenge because there's, I think, one gotcha that you might deal with when you're dealing with one of the languages. But mode, if you guys are not familiar, just a mathematical term, you're given input values, you want to figure out which one is the most prevalent, as in which one appears the most number of times. So the first example, we have 1, 2, 3, 3. In that case, 3 appears the most number of times. That's the mode of this input. If there's a tie, for example, this one, we have 1, 1, 2, 2. Both those are the mode of the input set. It's a little math for you there. Pad an array. This one's kind of cool. Basically, we give you an array, some value, and you need to output an array that has at least that many elements in it. If you pass in an array that's larger, then you don't have to update the input array. Pretty straightforward. Basically, understand the requirements, take the input, achieve the results with most of these problems. Balanced parentheses might be a little more challenging. This one, you want to find out, if you're familiar with coding, you need to have your parentheses, whether it be curly braces, parentheses, or square brackets, you need to have those matched. You can't have one opening one and not a closed one. So this one kind of tackles that situation where you need to identify an input string if it's properly balanced or not balanced. So that one's a little trickier, I think, but hopefully you guys kind of understand the situation there. In this case that I'm highlighting right here, that's not balanced because you have a closing parentheses before a opening one. So that doesn't make sense in terms of what we do. So those are challenges for today and the weekend. Hopefully, again, they're challenging enough. Hopefully you guys have the tools. I think you guys do have the tools in Python and JavaScript to tackle these. So for the afternoon, once you guys are back from lunch, definitely take an extra few minutes from lunch since I'm holding you hostage here. But yeah, once you guys get back, tackle these challenges, start anyone that seems appealing to you. We could have breakout sessions in the afternoon with the discussion groups if you guys want to go over one of them. You guys can pick a popular one and focus on that one. I'll say I'll go with Palindrome. If you guys do want to focus on one, focus on Palindrome, and we'll have discussion sessions on that one. That way, everyone's working on the same one if they want to have a later discussion session on it. But otherwise, pick whichever one you want to work on if you don't think you want to discuss the Palindrome.
So be back at 1:30.
All right.
Or you can start working at 1:30.
All right. Thanks, guys. Have a good lunch.
Thank you.
Thank you, Encore.